So good evening, everyone. This is Akshit, the web co-lead for GDSC VIT Bhopal, and today we'll be having our second session on NFTs and blockchain. And I hope you're all as excited as I am, and let's just get started with it. So before going on with the hands-on demo, I would like to go over what we discussed yesterday, and then we can take up some doubts if you had any, and then we'll get started. So we went on from seeing that on what all NFTs are there out there in Twitter, and how people are getting famous just by selling their NFTs, just by clicking their selfies and uploading them as NFTs. Then we discussed about what is a blockchain and what's the bookish definition of it and what actually it is. Then we discussed different chains and networks on the different EVM chains and networks which exist on the Ethereum blockchain. And then we discussed about what smart contracts are, and then we went over some DeFi protocols, and then I explained about why NFTs are getting so hyped and what are the use cases behind it. So if you have any questions from the yesterday's session, you can go ahead and send them in the chat, and if not so, then we'll just get started with the hands-on demo. Okay, I'll give it a minute or two and then we'll begin. Okay, great. So let's just get started. So the agenda for today is that we'll be first going over how to generate art or like with an automation process. Like if you see on OpenSea, there are different projects with a number of NFTs out there. So how do they generate their art? Like if we let's take the example of Bored Ape as we took yesterday. And as you can see that there are a number of items, like there are 10K items. So the artist may not must not have like drawn them by hand. So as you can see, there are certain similarities between each of the apes as well. So what they do is that they create different layers of the NFT art and then they randomize it. So that's how, and they run a script behind it, which like uniquely creates different NFTs based on different rarities. So if you see that we have different backgrounds associated with it. So you can, if I take the purple one, then you'll see all the NFTs that have a purple background. So this can all be randomized using JavaScript, and that's what we'll be doing today. So that's one point, and we'll be doing that with a this hashlips library, which is a GitHub repo, and we'll clone it and go ahead with it. Then we have Pinata. Pinata would be the tool to upload our NFTs to the content addressable network, which is IPFS. And then we'll code a smart contract using Hard Hat. Hard Hat is basically our development environment where we'll run a local blockchain, compile, write tests against our Solidity contract, and deploy it eventually. So we have OpenZeppelin. OpenZeppelin is a tool to write smart contracts. It helps you like have security features inside it. So you can just import it as libraries, and you can just go ahead and code it. And then we'll have Alchemy. Alchemy is basically an RPC which helps you deploy smart contracts on the blockchain. So if you're with me so far, I'll go ahead and start cloning the repo. Okay, we have a question. So why bored apes are the only most popular NFTs? So yeah, we talked about this yesterday, where you can see that bored apes came with the concept where they are inviting people to yacht club parties. So it got very famous on Twitter because of that. Then we had certain celebs who bought the NFT as well, which created more hype regarding that. Yeah, true. CryptoPunks is also one of the very famous ones, as it was the very first one NFT collection to come out. Yeah. So let's go ahead with the tutorial. So first, what we'll do is we'll go ahead with this Hashlips GitHub repo and clone it to our local system. So one second. This you can find this link in the chat and follow along if you wish. So this is the repo, and I'll just copy the SSH link and clone it. So I believe you won't be able to see my terminal yet. So I'll change my screen. I hope you can see my terminal now, and I'll just go ahead to a local directory on my system, and I'll just clone this repo. So the command for cloning a repo is git clone and just pasting in the URL. So I'm using an SSH URL right now, but it's not necessary. You can just do it with HTTPS, but it will probably ask you for a username and password. So let's move on. I'll clone this repo. And until this is cloning, we can go ahead and look at the README file. So the instructions are very simple. You just go ahead and clone it, install the dependencies, and then you have different traits that you can set. So as we saw on OpenSea that this Bored Ape was having different traits, like it has different types of clothes, different backgrounds, and such traits, different eyes. So that's what we'll be doing. We'll generate some different traits, which would be then randomized and put together, and then it will create an NFT for you, NFT art. So I believe it's cloned. So let's go into this directory and let's go ahead and say yarn. So I'm using yarn as a package manager for now, but you can also use npm. So the command for that is npm I. So the dependencies have been installed. Then we can go into the VS Code. So like at first this may seem very intimidating, but you just have to follow the instructions on the README file. It may seem intimidating at first, but it's very easy to generate. So we can just skip all this. We can just go ahead with a command, which is npm run build. So what this is doing is that it has different layers. We have a background, we have a bottom lid. If you see, there are different types of traits. So for the bottom lid, there are different types of traits. Then for eye color, we have different traits. So this is a project which is basically generating the eye, an eye art. So these are all the layers that we have, and these are all defined in our config. So if you see, we have defined the order of the layers. So the background will come first, and then the eyeball will come on top of it, and so on. So you can easily configure different layers. If you want your own art, you can just come in here and replace this image in this correct format, and you'll be good to go. And you can generate as many images as you want. So as you can see, the Grow Edition size 2 is set to 5 right now. So I'll just set this to 15. Uh, I'm planning on generating 15 NFTs for today's session, and we'll then upload it to IPFS. So I just set this to 15, and you can just go ahead and name your collection as well. So for today, I'll name it as uh, Google Student Club. Okay. And we can just give a description for it. NFTs for uh, second session, and we have a IPFS URI to paste here. So we'll go over this later. So first, we'll go ahead and generate the art. So for that, we have the command yarn build. And I don't even have these commands in memory. Like you can just go ahead and read the README, and it's pretty straightforward. So you can go ahead and enter this command, and it creates different images for you. So if you go to the build directory, you'll see that there are two folders, which first one is images, which has created this art for you, very simple. And then we have some metadata for it, which is in this JSON directory. So each of the NFTs has like associates a different JSON with it, which tells how rare the item is and so on. So what we'll do is that as you can see that we have a image URL over here. So we need to replace this image URL with an IPFS link. So the first step to do that is that we'll have to upload this images folder to IPFS, and then we'll recursively change the JSON files with the IPFS URL. So then we can just upload the JSON files to our IPFS, and then that will help us to mint the NFTs. So like so far so good, I believe. If there are any questions, you can drop it in the chat. Yeah, smart contracts are very much hackable. If you haven't written your smart contract properly and you leave some loopholes inside it, then there have been hacks, and I believe there always will be. So you have to be very careful while writing a smart contract. Any other questions? Okay, looks good. So we'll go ahead with the next step of uploading the images to IPFS. I'll just share my screen again. Sorry. Okay. So this is Pinata. Pinata is a service which basically pins your IPFS data. So you can just go ahead with Pinata. It's You'll find the link to it in the description or in the comments, and you can just go ahead and upload your files over here. So I'll upload a folder, and I'll just navigate to the folder that I had. So this is the Hashlips repo, and as I showed you before, we have the images in the build directory. So we can just select this images folder and upload, and it will give a warning, and then you can just name it. So I'll call it Google Student Club as we named it before, and upload. I also have created a Notion document for this. So if you want to refer back to it, all the steps for this are written here. So you can just follow this tutorial. You can just go ahead and get clone, and as I showed you, just showed you, whatever the steps for generating the images were. And you can even run a pixelate command, which creates a pixelized version of your NFTs. I'll show you that as well. So we created these NFTs, and now I can run yarn pixelate. And what it did was that it created another directory in the build folder, which is pixel images. And this just pixelated the NFTs that were generated before. So it's just trendy, and that's why they have given a feature of pixelating. So you can go ahead with this if you want. But for now, we'll just be uploading the normal images. So as you can see that the folder has been uploaded. So if I go to this, you can see that we have these images, and we have the hash for the folder, and we can just save this for now. So this will come in handy further. So that was the generation part. Yeah, the art generation part is very easy. You can just follow simple commands and generate tons of art. And now we have to upload the metadata for the images. So as you can see in the build folder, like all of these JSON files have a URI to be replaced. So this URI is basically the URI which was the IPFS hash, which we just generated over here. So we won't do it turn by turn and just copy paste it in every file. There's a script for that as well. If you go ahead with the README and read a little bit ahead, you can see there's this update info command. So what this will do is that it will recursively just go through each and every JSON file and update the IPFS URI in that. So you won't have to go through it manually. So I'll just go with that command. You can go to config.js, and you can just update this new URI to replace with the IPFS hash, and just run the command yarn, what was it? Update info. So I'll paste that and done. So if you go to the build folder again, you can see that the IPFS hash has been updated in each and every JSON file. Very simple procedure. So we can go ahead and upload this JSON to like these JSON files to Pinata now. This will come in handy while we're coding the smart contract. So it was in, yeah, build folder. and I can just upload this JSON folder. I'll call it Google Student Club JSON, and this will take a minute or two, and then we can move on to the next step. It hasn't updated yet. We'll see. Okay. So the next part of it is initializing a React app. So for this, for the front end of the application, we'll be using React, which would be generated using create React app. And don't worry, like if you're not familiar with React and you're just a newbie and you're familiar with HTML and CSS, that's very much okay. You can come back to this tutorial whenever, and we won't be going into much complex parts of React. It will be very easy if you follow along. And if you have any doubts, you can drop them in the chat. I'll just pause for a second. Okay, looks like everyone is familiar with React. So we'll move on. So we'll come out of this directory now and we'll generate a React app. I'll say, and I'll use Yarn for this. So I can just say create React app and let's call this NFT tutorial 2. Okay. So this will generate a React app for us. And the next step is to initialize hard hat. So coming to hard hat, as I told before, hard hat is a development environment tool, which is like an alternative to Ganache. If you're familiar with Ganache, in the last tutorial, even I gave a demo for it. So hard hat can be used to run a local blockchain, deploy the smart contracts, and even perform tests on your smart contracts. So we'll go ahead and install hard hat to the project. So before doing that, I'll just open this project in VS Code so you can have a better idea. Okay, I opened the wrong folder. Yeah, so this is what a React app looks like. So the main file is app.js, and I'll just start the app to give you an idea of what it looks like. So this is our React app running on localhost 3004, and we can go ahead and make changes to this. So I'll get rid of the boilerplate and I'll turn this into a div and get rid of the logo. And I have some CSS that I have already written so that we don't have to concentrate on the CSS part today, which should be in source app.css. And you can just go ahead and copy the CSS from here. We'll have the link in the description below. Let's go to app.css and paste the CSS. Yeah, and we're good to go for now. So moving on, let's install hard hat. So the command for installing hard hat is npx hard hat, and that's it. Just press enter, and it'll ask for a like it'll ask if you want to create a sample project. So we'll go with the basic sample project for now because it's easier to understand. And you can go ahead and say yes to git ignore. You should always have a git ignore in your project so you don't push any sensitive information to GitHub. And you can press yes to this as well because these are the dependencies that will require. Let's look at the next steps until then. Once this is installed, we'll go ahead with that. So we'll also install another dependency, which is OpenZeppelin smart contracts, which you can easily just code smart contracts, and like you can customize it with these options, and you can just copy this, and you can use the OpenZeppelin smart contracts as a library. So it will be very easy boilerplate. This is the link for it if you want to check it out. It will be in the comment section. Also, if you haven't made an account on Alchemy yet, I would suggest you could go ahead and make that, because we'll be requiring it for deployment on the Polygon Mumbai network. So go ahead and make an account on this. Yeah, so the dependencies have been installed. We'll move on to the next steps. So once you have installed all the dependencies, we'll have just one dependency left, that is OpenZeppelin smart contracts. And you can go ahead and add this as a dependency. And that will allow you to import the base smart contracts, which are the ERC 721 smart contracts and so on. So I'll open it in VS Code. And as you can see, we have a config file here for hard. So this part we can just get rid of. We won't be needing this today. And what we'll do is that we have to make some changes over here. So what happens is that when you compile a smart contract, see we have a sample smart contract here. So when we compile the smart contract, what it does is that it converts it into bytecode, and it generates some artifacts called ABI. Don't get it confused with API. It's ABI. So it's called Application Binary Interface. So I'll write it here. So what this does is that helps you to it helps you to like interact with the smart contract. So you can easily go ahead with this front end. You can import the ABI to your front end and just make calls to your smart contract functions. So that's why this is required. So for that, we need an output file. So that's what we'll configure in the hard hat config.js file. And you can just copy the paths from here. So we need a paths object, and we just tell it that the artifacts should be generated in the particular folder, which would be in source/artifacts. So when I run this smart contract, when I compile it, the artifacts there would be an artifacts folder here generated in the source folder. So that's why it's required. So moving on to the next step, we'll have coding out the smart contract. So if you're with me so far, you can drop a thumbs up in the chat, or if you have any questions, I'll take that. This might be a little intimidating. No worries, Harsh. You can always come back to the tutorial if you're late. Okay, great. Looks like you're with me. So let's go ahead and code the Open Zeppelin smart contracts now. So there will be a link in the chat which helps you. It's a wizard basically, which helps you write a smart contract. So I'll just go ahead and duplicate this tab, and we'll write it from scratch. Yeah. So before going ahead with the Solidity tutorial, I would first like to discuss the different token standards that we have. So as you can see, we have three options here, like ERC20, ERC721, and ERC1155. So ERC20 tokens are basically all the cryptocurrencies that you see, like for example, Ethereum or USDT or USDC, all the ones that are listed on CoinMarketCap. Not Bitcoin, because Bitcoin is on its separate blockchain. But if you go ahead and see, we have this USD, USD, USDC, USDT. All the tokens that are on the Ethereum blockchain are mostly ERC20 tokens. So if you want to go ahead and study more about it, you can go ahead to the Ethereum docs and you can study more about it. So what the standard defines is that every standard has its own set of functions that a token should always have. So an ERC20 token per se should also have a name function, a symbol function, a total supply function, and so on. So these functions are the part of the standard, and these like comprise of various functions which are necessary for the token to be transferred or put on hold or whatever. So today we'll be going over the ERC 721s, which are basically your NFTs. So ERC20 tokens are your fungible tokens. So ERC20 are the fungible ones, and ERC 721 are the non-fungible ones. And thus the name non-fungible tokens, NFTs. So what does fungible actually mean? Fungible is basically like it may have duplicates. So you can't differentiate two USDT coins or two ERC20 tokens. You can't differentiate between them. They are exactly the same and they have exactly the same value. But it's not the same case with ERC 721s. Each of the tokens are unique. Like this NFT is unique to this NFT. Like they are totally different. So they can be uniquely identified. So that's what ERC 721 token standard brings. And then we also have ERC 1155s. So these are basically semi-fungible. They can be differentiated, but they are produced in a limit. So ERC 115s are also there. But today we'll be going through ERC 721 tokens, and let's go ahead with it. So let's name the token as Google Student Club, as we named it before, and we can give the symbol as GDSC. So this symbol basically stands for the symbol that you're giving. Like for Bitcoin, it would be Bitcoin is basically the name, and the symbol for it is BTC. So that's how it is identified on the blockchain. So that's one part. Then we'll add a mintable part. So what it's doing is that all the ERC20 functions that we had according to the standard, we are importing it from the Open Zeppelin smart contracts. So we don't have to code it from scratch, and we don't have to worry about the security of it. So it will be very secure. But we can't totally trust it. But almost everyone is using it, so and it's gone through many audits, so you can fairly trust it. But if you still have your like you have still have doubts, then you can code it on your own as well. Then so the mintable function, what it does is that it allows the token to be minted. So like the only owner keyword, what it does is that it's allowing the mint function only to the owner. So if I'm deploying this smart contract using my wallet address, then only my wallet address can access this mint function. So that's what it does. So I don't have to pay a fee for this. I can just directly mint the token. Only the gas fees will be required. So that's that. And we have different options. We have burnable. So if I press this option, what it will do is that you can even burn the token. Like burning means that basically destroying the token so no one can hold it. So we won't be doing this today. And then we have different voting mechanisms possible. And like there's a whole lot of customization that you can adopt. So like we wanted to be on ERC 721s actually. So let's go on to ERC 721. So the base URI is the basically the asset image. So like for this token, we have this image. So if I open this in new tab, we have to have a link. Right now, OpenSea is centralized, so it's using Google for its backend. But what we are using is IPFS. So the base URL for our assets would be IPFS colon slash slash. So I'll say IPFS colon slash slash, and this is the base URI for our images. because all of our images will have the format of IPFS colon slash slash the CID and then the name of the image. So that's how it's working. Then we'll say it's mintable, and we'll also add an auto increment ID. So what this will do is that we can keep a track of how many tokens have been minted, and we can also check like what ID of the token is minted. So we'll create certain functions inside the smart contract, which will be certain util functions, which will help us do that. Then we also will take the URI storage part. What this does is that we have certain traits which are associated with our NFT. So the URI storage part helps us fetch the contents from the JSON file and show it on OpenSea. So that's what it does. The traits that we talked about before, which were on the sidebar, let it load. Uh, yeah, so all these traits are basically the part of the URI storage. So that's what we'll do. And I guess that's all. We can just pick the smart contract from here, and we can also open it in Remix if you want. Like if you prefer Remix over VS Code, you can even code it here. But today we'll be going over VS Code only because I prefer VS Code over Remix as it gives you linting options as well. So I have Google student club .sol, and yeah. So the first thing to note is that name of the file should be matching with the name of the contract. So this is a convention that everyone follows, and it won't have like you won't face any problems further while deploying it. It's just convenient. So as you can see, the smart contract right now looks very intimidating even to me. So we'll go line by line and just figure out what is actually going on this smart contract. So the first thing that we're doing is that we're importing counters. So this is basically a utility function. What it does is that it just keeps count. So it's just keeping count of whatever tokens are minted. And we have a constructor function. This constructor function is called only when the contract is deployed, and then it is never called again. So it accepts a name of the contract and the symbol of the contract as we saw before. And if you go into the ERC 721, you can even see that it's accepting the name as well as symbol. But I'd suggest that you do not like touch this file because it may cause errors in future. So if you're curious, you can go ahead and read that file, and it'll give you more insight into how ERC 721 tokens are being used. Like if I go inside here, you'll also find those functions that we talked about in the ERC 721 standard. So you can even call these using like by calling the smart contract. So we are inheriting the properties of the ERC 721's SOL files and the URI storage files, as well as the ownable files. So what we'll do is that our NFTs are starting with the index number of 1. As you can see in the pinata, we have the index of it is from 1. So to customize that, what we'll do is that we'll increment token ID counter when it's deployed. So we'll just do this, and we can just say increment. So that will just increment the counter to 1 once it's deployed. So we'll go over some more functions that we need to design, uh, which is which is written in the doc. So these are the functionalities that we gave. If you wanna like come back and see what all we did, you can always refer back to this doc. So yeah, so first of all, what we'll do is that we'll create a mapping. We'll create a mapping of URLs to whatever tokens that have been generated. So uh, I'll just copy this code and paste it here. So what we are doing is that we'll say that if a particular URI has been minted, we'll set it to 1, so that we know that the URI has already been minted and no one else can mint it again. So that's what the purpose of this is. And we have this pay to mint function that we'll be coding out. what it does is that it just accepts the recipient's address. As you can see, the data type of the recipient is address, and it accepts a metadata URI, which is basically the URI uh, of our JSON files that we uploaded before. So that's what it is, and let's just copy this function and bring it to our smart contract. So let's go over what all things are in this. So we have this it as a public function. So anybody can call this function, even me, or like even anybody from you in the audience can call it. And we have this payable keyword. What it tells is that certain amount of money is like associated with it, with this function. So it is accepting some amount inside of it. So that's what the payable is referring to. Then it just says that it's returning a uint, which is basically the item's ID. That's all. So, and as you can see, we have this require statement. So it looks intimidating at first, but it's not much. It's just like an if statement in JavaScript. So if you wanted to write this in JavaScript, this would be your condition, and this is basically the else block. So if I code it in JavaScript, it will be like this. I'll say if existing URI is this, then I'll continue, and otherwise I'll just say that I'll just throw an error. So it will look something like this if I coded this in JavaScript. So it will just throw an error that the NFT has been minted. So the require statement is just like it's only in Solidity, so that's what it's doing. So we are just checking if the metadata URI has already been minted, and if it has been minted, we throw an error, and then we check for the amount of ether that we are accepting. If it's below this level, like if it's below 0.05, then it will throw a message that you need to pay up. So, like we'll be deploying this to Polygon mainnet, Polygon Mumbai net. So let's just keep the price of this as like super low. So we'll keep it to 0.005 ether. And as we'll be deploying it to like Polygon, so the ether here just represents the native token of the blockchain that we're deploying it to. So this would actually be Matic if we'll be deploying it to Polygon. So yeah, so it's simple logic. So we are just asking the user to pay to mint a token. We are checking some conditions that if the conditions are being met or not. And if so, if the conditions are fine, then we'll just increment the token counter by one, which would be the new item ID of the token. And we'll just increment this, and we'll set the existing URIs to one, which will just be which will just help us identify that the metadata URI has been minted, and we'll just mint the token. So this underscore mint token function actually comes from your ERC721.sol file that we have imported here, and even the set token URI does the same thing. So these are the basic steps with which your token is being minted, and all these steps are just for utils and your security. So let's move on to the next function. So we have the is content owned function. So this is another utility function that we're coding. And what this will do is that it will just like we can just call this, and it will just tell us whether the token has been owned or not. So uh, let's just rename this properly, and it's just checking a condition. If the URI is already owned, then just send true, otherwise false. As you can see, the return type of it is Boolean. And as we are not performing any mutations in this, which is that we are not mutating any variables of the smart contract, we label it as view. If I remove this view, it will throw an error, basically a warning that this can be restricted to view as it's not mutating any of the variables. So let's just bring it back to view. And the next function is total minted, which will just return the number of tokens that have been minted. So we'll paste that here as well. And this is a view function as well. So that's it for our smart contract. It is super easy if you If you like, you don't have to remember each and everything. You can refer back to the docs. Even I'm not doing this from memory. I also refer back to docs each and every time. So that's it. So, and if you want to make your smart contract secure, you have to refer back, or it could definitely be a vulnerable program. So that's it for the Sol program. And now we can go ahead for the next steps, which is run a local blockchain. So before this, if anyone has any questions, they can drop it in the chat because this is a lot to process. Any questions so far? Okay, good. Looks like everyone is familiar with Solidity. Let's move on to the next part. So yesterday, what I showed was that running a local blockchain using Ganache. So you can either use Ganache or you can use Hardhat. And I'll be using Hardhat for today, as I showed Ganache before. And Hardhat actually comes with a lot of helpful functions as well. So it helps us like code it very easily. So I'll just go ahead and say npx Hardhat node, and this will just spin up a local blockchain. And we have different private keys and accounts, and we will be importing this into our MetaMask further. So I have written a test case like for maintaining, like for just testing out your smart contract. You don't have to code it from scratch. You can just take tests and you can just paste them here. So we'll be going over how it's actually testing it. And what we'll do is that as our smart contract's name is Google Student Club, we'll be replacing it in the sample test. So let's just go ahead and change this. We'll rename this to this. And so what we're doing is in the first one, uh, like if you read it from top to bottom, you'll probably understand it. It's basically describing the smart contract function. And the next line says that it should mint and transfer to someone. So we're just checking if it's minting and transferring it to someone. So before coding out the front end, we actually write a test to make sure that it's not vulnerable. So whatever functionality that we're doing here, we'll do the exact same functionality on the front end as well. So the first step is to check if the like if it's minting and transferring it to someone. So we just get the smart contract by this method of ethers. Ethers is the library we are using for the front end, and we are just getting the smart contract, and then we're deploying it and getting instantiating one instance of it, and we are waiting until it's deployed. So once it's deployed, we add a recipient to it and a metadata URI. So for the recipient, I'll add one from from the account here. So the account 0 is basically like your username, and the private key is basically like your password. So I'm revealing this because it doesn't matter, as I'm running a local blockchain and nobody would able to steal funds or something, as this ether is actually fake because it's not on mainnet. So we'll go ahead and paste it link here. And we have the metadata URI, which is basically our image. So we can just put this as one.png, and this will be our CID. So we can go ahead and run this transaction. So for the command for that is, we can say npx hardhat test. So that it will do is that it will compile the Solidity contract, and it created the artifacts directory as I told before, and it contains the ABI for the contract. If you go to the Google Student Club.sol, here is the ABI. So this will help us in interacting with the smart contract. So uh, as you can see that our test passed. So let's try and fail the test for once. Like set the limit for minting the token as very low, which was, I believe, 0.0005. So I'll just pick this and put an amount here, which will be as 0.0004. And I'll try to run the test again. See, now it throwed an exception and it says need to pay up because the amount that was required wasn't fulfilled. So if I just turn this to 5 or maybe 6, then the test case will pass. So see, the test case has been passed, and that's it. So this is how you write a test for it. Right now, I have just written it for mint and transfer to someone, but you can even write it for whatever the like you have to write it for all the functions that are public basically, so that you don't have any vulnerabilities lying around and people can't penetrate your Solidity smart contract. So that's all for the test, and we'll move on to the next step. So once this is done, what we'll do is that we'll deploy the smart contract on our local chain. And like we have a script already here for us. Like if we go to the scripts directory, we have this sample script.js. So what it's doing is that it's taking this greeter.sol and it's deploying it to the local blockchain. So we'll just get rid of the stuff that we don't need, all these comments, so that it looks cleaner. And we'll replace this greeter with our Google Student Club. And as you can see that it's actually giving a parameter which is hello hard hat. We don't really need this because our smart contract isn't accepting a parameter, and we can change this to small as it's just an instance of the smart contract. And over here as well, or was it? One sec. Yeah. So yeah, that's the sample script, and you can just pick the script from here and change it accordingly based on whatever the name of your smart contract is. So we'll go ahead and uh, like we are running the local blockchain here. So we can go ahead and compile the smart contract, and the command for that is npx hard compile. And it says nothing to compile because while we were testing the smart contract, it already deployed it. So it already compiled it. So we don't need to do that. So we'll just run the script, the sample script that we wrote just now to deploy it on the local blockchain. So the command for that is npx hard hat run, and just point it to the script section and the network. So network we'll choose as localhost for now, as we're running a local blockchain, and it will prompt you with the smart contract address. So what you can do now is that you can make a new file and name it as .env. And this file is basically your environment variable file, which is basically for all your sensitive information like passwords and secrets or API keys. So you don't really push this to GitHub. So if you can see in the gitignore file, the .env file is added to the gitignore, so it won't push the file to GitHub. So we'll create a variable here as React app contract address, because we need to prefix it with React app as we if we want to import it in React. So this is a requirement for it. So uh, this is the smart contract address, and now we can go ahead and code our front end. So as we saw before, this is our front end. Right now it's blank. We'll go ahead to the app.js, and first of all we'll try and get that contract address and see if we have it there. So I'll say process dot env dot the name of the variable. So this is how you get access the environment variable, and you can just try and log it. So if I go to the browser now and see the console, we have this contract address as undefined right now. That's because the React app was already running. So whenever you change the environment variables, you have to run the React app once again. So I'll just exit out of this and start the app again, and it should be up and running. And as you can see, we have the contract address. So the next step is that if you do not have MetaMask installed, go ahead and install MetaMask, as we'll require it for testing. And yeah, so the first step would be to fetch the wallet balances, and we are on the localhost. So let's switch to localhost. And on the account 3, we have 10,000 ETH, which are basically fake Ether. And yeah, so what I like to do is that in the source directory, I like to create a components folder. So all the React components that we'll have, we'll put it in here, and then we can import it into the app further. So let's create a React component called wallet balance, and we'll put an extension as .jsx. So I have a shorthand installed, which will just auto update the script, and it'll just auto complete it. So we have wallet balance. Now what we'll do is that we'll create a use state. We'll create a state variable which will store our wallet balance. So I'll say wallet balance, and we'll initialize it as 0. So the wallet balance can be shown here. I'll put it in an H3 so that it's visible, and I'll say wallet balance. So if you're not familiar with useState, it's basically a state variable. You can just store an initial value in this parameter, and you can access it here. If you wanted to update it, you can just pass the value inside set wallet balance as a parameter, and it will update the state variable. So we'll be seeing that further. As of now, let's just import the wallet balance component in our main app. And if you see, now it shows that our wallet balance is 0. So what we'll do is that we'll create a button to get our wallet balance. I'll say get balance. And if you refer back to the doc, we have a function over here which will fetch the wallet's balance. So I'll just paste it here as we're on a time crunch right now. So ethers is the directory. Ethers is the dependency that we installed before, which is basically for interacting with the blockchain. And we can set the wallet balance as this. So the get balance function can be called on clicking the button. And as you can see, what it's doing is that it's just requesting for the Ethereum accounts. And what it will do is that it will just return you an array. And I've destructured the account from here. So the account can be further used to get the balance using a provider. So this comes in like it comes in with ethers. You can look this up if you want, but like for starters, you can just copy paste this if you're like new to it. So the provider is basically giving you all the utils, and whatever contract calls you have to make, you do it using the provider. So we'll get the balance, and we'll set the wallet balance in the format of ether once it's clicked. So I'll click on this, and the wallet balance updates to 10,000 ether. And I can even add ether word here just to make it clear. Yeah. So say the user hasn't installed MetaMask on his browser. So what we can do is that we can have a check here, and if the user hasn't installed it, we'll show an error. So I'll say I'll call it no metamask.jsx, and I'll say go install MetaMask, and we can paste in a link to install MetaMask. So we'll create an A tag, and we can just paste the MetaMask URL. And the way to check if the user has installed a MetaMask wallet or not, what you can do is that you can access the window.ethereum object. So you can check whether it exists or not. So if this object actually exists, we can just go ahead and render the wallet balance component. Otherwise, we'll just render the no MetaMask uh, component. So as I have MetaMask installed, it's showing me this. Let's go on to an incognito window and check whether it's showing that on that window as well. So yeah, this is an incognito window, and I'll go to localhost, and it says that install MetaMask. Okay, I spelled it wrong. So yeah, so this is how you conditionally render a component based on if the MetaMask wallet is installed or not. So the MetaMask wallet, what it does is that it injects the window.ethereum object in your browser so that you can have access to all the functions inside Ethers or Web3.js. So that's the easiest part. Then let's move on to a little complex part. Now, what we have to do is that we have fetched the balance from the wallet. So this is the structure that I'm following. So we have the install button. This is basically the no MetaMask uh, component. And we'll go ahead and create some more components. We have created this wallet balance. Now we'll create an NFT image component as well. And we'll put some function inside there. So yeah, let's go ahead and create a home component here. So this is the home component. And rather than rendering the wallet balance, what I'll do is that I'll render a home component here. And if you're wondering how I'm auto importing this, you can just go ahead and hit control space, and it will give you a prediction for that. So that's how it's done. And you can remove the wallet balance from here and import it here. So we have that. And you can see our wallet balance is 0 Ether. Okay. So what we'll do is that we'll import the ABI now in the home.jsx. I hope there's not much disturbance on my side. Sorry for it. So what I'll do is I'll import the Google Student Club. So this is importing it from the artifacts directory, which is in the contracts, and we have Google Student Club, and this is where I'm getting this. And we'll get access to the Google Student Club ABI from the .abi. If you go into this and you search for ABI, look, this is the ABI which I was talking about, and you can use this to interact with the blockchain and the smart contract. So what we're doing is that we got the contract address, but this is some other contract address. We'll fetch it from our process.env. So let's get that done. So this is the smart contract address. and we instantiated a provider here and generated a signer, which is basically used to sign transactions on the blockchain. And this is the instance of the contract which we are using ethers.contract to fetch it. So this is basically the only part that's a little confusing at start, and you can just go ahead and call the functions from the contract now. Say let's open the smart contract again. Say I wanted to like call this pay to min function, I would just easily do it using contract dot pay to min, and that's it. So that's how easy it is to run a smart contract. You just have to enter the right params or it will fail with an error. So this is how it's working. Let's move on to the next function. So these are the functions to interact with the smart contract. So this function is the get total minted that we talked about. So what it's doing is that it's just fetching the total minted NFTs that we had, and the mint status is will check if the content is owned. It's basically all we have just translated our Solidity functions to JavaScript. So we can just copy it from here uh, as we are running out of time. So let's go to app.js and we have home. Okay, so let's navigate to home. So I'll just copy this code from home and here. So rather than the test one, we were using Google Student Club. If I click on this, it will open the Google Student Club.json API, and that's how we get it. Now, what we have to do is that we have to add the IPFS hash that we uploaded to Pinata. So if you see, this is the IPFS hash for the folder of the image. So we'll copy this and we can just paste this hash over here so that we can access the IPFS image, and we'll also create the hash for the image, like for the JSON as well, which will be over here. So this is the hash for the JSON file. So if I paste it here, so this is how I'm generating the metadata URI. I'm just passing the hash, IPFS hash, and the token ID, and the token ID is being mapped from an array. And the array is being built from a total minted variable, which we are fetching from the smart contract. So as you can see, the contract total minted is coming into this variable, and we're just setting it to total minted. We're passing it to int. So that's how it is. And if I go ahead and run it, as you can see, this is what it looks like. Let me just check the code once, and then we'll go ahead and mint a token. I hope I'm not missing anything. Looks good. Okay, so now that we have done this, we'll try to mint a token. So now the transaction has come and it's asking for 0.05 ether. So why is it asking for 0.05 ether? Like we have our smart contract asked for only 0.005. So what we'll do is that we've actually asked for 0.05 on our front end. So we'll fix this. And now we can reject this and try again. Yeah, now it looks good. So whenever you're making transactions using MetaMask, always check the balance that you're spending. Also, it's very important to look at the estimated gas fees, as The gas fees on Ethereum mainnet fluctuates a lot, and it goes really high, approximately like $100 or so at times as well. So it's very important to look at the gas fees. So we'll confirm this transaction, and it failed for some reason. Okay. Let's check once again what the issue is. Okay, so this is an error with hard hat at times. If you overuse one of the accounts on a local blockchain, it errors out. So what we'll do is that we'll pick one from the end and try it with that. So we'll remove this account. No, not this one. I believe this has Polygon funds on it. Oh yeah. So we'll import an account and I'll paste this private key as a duplicate. I'll try another one. Looks like I already imported that one. So we'll go to accounts, import account, paste the private key, and now it's imported. And if I check the local host, I have 10,000 ETH, and if I get balance, it's working. Let's go ahead and try to mint it again. Confirm. Okay. For some reason, it broke. 1 second. Let's try this again. I believe the smart contract address is probably not right. Let's close it. Yeah. So this happens at times. I'll just try to recompile it again. Yeah. Okay, so what I did was that I didn't actually connect my wallet here. Probably that's why it was calling it. Yeah. So now the transaction has been confirmed. And if I reload the page, I should have my NFT here. So I can mint another one. Let's try again. Another one confirmed. And if I reload the page, we have another NFT. So that's how you create an NFT and how it's generated. And this is right now running on our local blockchain. So we'll just go ahead and do this on Polygon MumbaiNet as well. So before doing that, let's just pause a while. And if you have any questions regarding this, you can drop it in the chat. Okay. Yeah, Zeppelin handles the security aspects on its own as well. But you like it handles most of the security aspects, but you also have to look for the like you have to check out the functions that you're creating as well. So like you like the public functions that you're creating has to be audited because the payable functions as well, because the payable functions are the most threatening ones, as it's dealing with funds. So funds can be lost as well. And there have been many cases where there have been smart contract hacks and people have lost billions. So it's very important to audit these contracts. Yeah, sure. You should rewatch the session because it's a lot to process. Yeah. Okay. So let's go ahead and deploy it on Polygon now. So the prerequisite for that is that you should have to have an account on Alchemy, which I told before. So if once you enter the Alchemy dashboard, you have an option to create an app. So I've already created one for this tutorial. It's called My First App, and you can just copy the HTTP view, the key, and put it in your file. So I'll be doing this off camera because this is a little sensitive. You can refer back to the doc if you want. The instructions for that is mentioned there. One second. So I'll just show you in the document what I actually did. So what I did was that I opened the hard hat config file and I added this networks object there. And the Alchemy URL that you take from the dashboard, you have to enter it here. And you have to just pick an account which has some Matic on it from Mumbai mainnet or like Mumbai testnet or the mainnet if you're deploying it to that. And the way to do that is you can visit some faucets. So Polygon, this is the Polygon faucet, and it just sends you free Matic because it's a testnet, so it doesn't really hold any real value. But you just have to paste in your wallet address, and it will send you some free Matic, and you can just then you can use that to deploy your smart contract. So that's how it is. The one last step I'll just do is real quick that I'll add my private key in the code off camera, and then I'll come back to the stream. One second. So I'll also show you how to actually export your private key if it's on um, if it's on your MetaMask. So I'll share it again. Yeah. So if you go to MetaMask and like there was an option to import an account. So what you can do is that if you have an existing account, you can just go ahead and go to the account details part, and there's this export private key option. So you just have to enter your MetaMask password, and it will just show you your private key, and then you can just inject it into your code, which I've done here over here. So then you'll have your network setup, and the next part is very easy. Uh, like we just ran the sample script to deploy it to the local host, we'll be doing the same thing. Um, we'll run the same command, but rather than choosing the localhost network, we'll choose Matic as we added this. So I'll go ahead and say Matic, and it should take a second or two, and it will deploy. Until then, we can go to OpenSea, and I'll say Mumbai testnet because we're deploying it with that. And there will be an option of getting listed. So if you like, if you deploy a smart contract, you can just choose the Mumbai network, and you can enter the address of your smart contract, and it will be listed on OpenSea, and anyone can go ahead and buy those. So I'll go to the terminal and let's see. Yeah. So it says that Google Student Club has been deployed to this smart contract address, and I'll go to OpenSea and paste in that contract address and submit. Okay, okay. 1 second, I think it has to load probably. Matic. Okay, maybe it's taking a little time to be deployed. Okay, as of now, we actually didn't mint any tokens. So let's go ahead and mint them because the tokens that we minted were actually on uh, like your local host. So what I'll do is that I'll paste in the contract address in the .env and restart my React app. And now I'm connected to Mumbai Testnet. And if I fetch my balance, it's now actually it's Matic rather than Ether. So let's go ahead and mint it. So it's prompted me for 0.005 Matic, which is basically gasless, and the gas fees on Matic is very low. So it'll just cost you a rupee or two to deploy your NFT projects on Matic, and I'll just confirm. And once the transaction confirmed notification comes, my NFT will be minted, and there you go. The NFT is minted. I'll mint another one. So that's confirmed, and we have minted. Okay. So now I'll just go ahead and paste that contract address on OpenSea, and hopefully it shows up. Yeah. So now has shown up, and as you can see, we have this NFT listed on OpenSea. And anyone can make an offer to sell this NFT. As I own it, I can even go ahead and do a auction of it, so that like you can list it on OpenSea on any of the networks. So this is how you actually mint it, and whatever NFTs you mint will show up on OpenSea over here. Like if I mint another one, it'll show up there. Yeah, okay. Now the transaction's confirmed, and we have another NFT. So you can mint up to 15 NFTs because I entered 15 where the IPFS link was. And now if I refresh this, the third NFT, like it says 3 items and it says one owner because I've minted it with the same address. And yeah, so that's it. That's how you create an NFT project and deploy it. So yeah. And as you can see, you can even go to the properties and check out the traits that I was talking about. So we have background as black, bottom lid as low, and these are all the properties or traits that we generated using hash lips. So this is it. And the description that you mentioned in the JSON file also comes here. And for some reason, it's not showing up here. Uh, we'll check that out later. But now you can see the token standard is ERC 721 and it's deployed on Mumbai. So that's how it's done. And yeah, that's it. If you have any questions, you can leave it in the chat. Yeah, sure, Shade. We'll send the PPTs over. I'll put it in the chat. Okay. Yeah, looks like that's it. Any other questions? That actually depends on you. Like if you want to create, like if you want to set a limit on how many NFTs you want to generate, you can just set that in a smart contract while like editing the pay to mint function that I talked about. You can set a condition, a require condition over there. If it's exceeding that, then you can stop then you can just throw the error and the person won't be able to mint. Yeah, looks like that's all the questions we have today. Yeah, thank you everyone. And be sure to fill the attendance form. It's in the chat below.